Hey everyone, I am Jane Kaldi. Today I will be presenting my seminar on first come first serve scheduling. This work is submitted to Madam Sumana from CSE Department, JM University. In this presentation, I will be explain the concept, implementation, experimental setup, result, and conclusion of FCFS scheduling algorithm. We will go to the content. These were the major sections covered in my presentation. Introduction, objectives, problem statement, implementation, experimental setup, output, and conclusion also. I will be go through each part step by step to clearly explain the FCFS scheduling technique and its importance. Next, we can go through the introduction. Our operating system plays a major role in managing hardware and executing processes. Among its important function is CPU scheduling, which decides the order in which processes run. Good CPU scheduling improves CPU utilization, response time, and overall user experience. There are several scheduling algorithms like SJF means short job first, SRTF, priority, and round robin, etc. But in this project, I am focusing specifically on first come first serve, where the processes that arrives first gets executed first. It is simple and easy to implement, but it also has limitations, which we will see later. Objectives. Next, we can go to the objective slide. The main objective of this project is to design and implement an FCFS scheduling simulator. We aim to accept dynamic arrival and burst time, calculate performance metrics such as waiting time, turnaround time, and response time. Test the performance on three different datasets. Understand how FCFS behaves under different workloads, and identify issues like convey effect. Finally, determine whether FCFS is suitable for real-time system. These objectives help analyze both the strength and weakness of the first come, first serve algorithm. Next, we can go through the problem statement. Efficient CPU scheduling is important for system performance. Although its first come first serve is a very simple, its performance varies depending on the type of processors. So the problem is how can we design and test an FCFS simulator that handles dynamic arrival times and evaluates key performance matrices. We also need to compare different datasets and see whether FCFS can support real-time requirements. This study ultimately helps understand where FCFS work well and where it fails. Next, we can go through the implementation. In our implementation, we created a process structure with the following fields: process ID, arrival time, burst time, start time, completion time, waiting time, turnaround time. We calculated waiting time and turnaround time. Is there a formula for both of that? Waiting time is calculated using this formula: start time minus arrival time, and turnaround time is using this formula: finish time minus arrival time. Three data sets were used to observe changes in performance. From these calculations, we generated Gantt chart and output tables to visualize the scheduling clearly. Next, we can go through the experimental setup. For the experimental setup, the programming language is used as C. I used Dev C++ as the compiler, and the platform is Windows. Input provided to the simulator were process ID, arrival time, burst time. Output generated as waiting time, turnaround time, Gantt chart, average computational values. This setup allowed us to test different datasets effectively. And we can go to the output. This slide displays the output of my FCFS program, first come, first serve program. It includes the Gantt chart and the performance matrices for all processes. The output clearly shows the execution order based on arrival times. From the results, we can easily observe the waiting times and turnaround times, which differ depending on arrival and burst times. Next, we can go through the conclusion. FCFS is the simplest CPU scheduling algorithm and execute processes in the order they arrive. It is easy to understand and implement, making it ideal for basic systems also. However, it is not efficient for large or mixed workloads and suffers from high waiting time due to convey effect. It does not prioritize short or urgent processes, so it is not suitable for real-time systems. Thus, FCFS is good for simple environments but not recommended where performance and deadlines matter. Thank you.